Let's now look to see if we can figure out some side lengths once we know a particular angle. And so we talked about how we could do that in special right triangles like 30, 60, 90 triangle. We know the relationships between the sides. So if we know one, we can find the others. The same thing in a 45, 45, 90 triangle. If we know one, we know the others. Well, now we can start to do that with these ratios that we've been talking about. So here we have a right triangle in number 1, where we know one of the side lengths, which usually is not enough to know the other two sides, but we also know an angle with 20 degrees. And now with our relationships, our ratios being constant through a particular set of triangles that has the same angle, we should be able to, at least at this point, do some estimation of the side lengths. And so let's go ahead and figure this out. So here's our angle, and we're asked to find what side length AB is. So side AB here, if we're going to, let's call it X. All right. And so looking at our two sides then that we're working with, we're trying to find X, and then we have the hypotenuse. And remember, side X then would be the adjacent side. All right. So the angle right here is going to be important because we're going to need to think about what is the adjacent divided by hypotenuse. So X divided by 8.5, again, so that's the adjacent divided by the hypotenuse. What is that for a 20-degree angle, right? So let's look that up. Let's look at adjacent divided hypotenuse for a 20-degree angle. I'm going to write that up here just as a reference. So we're going to have to go back to our chart and say, okay, 20-degree angle, adjacent divided by hypotenuse. Here we go. Adjacent divided by hypotenuse for a 20-degree angle is 0.940, 0.94. All right, so let's bring that down here. So we know that ratio is going to work out to be 0.94. Now we can solve for X. We have a little one-step problem here, one-step algebra problem, or maybe you could even set it up as a proportion here and cross multiply and divide. But if we're solving this, to undo this dividing, we can multiply both sides by 8.5. That does here, 8.5 times x divided by 8.5. Those cancel out to 1, so you just have 1x or x. And then we can multiply these two together, 0.94 times 8.5. And when you do that, you get 7.99. 0.94 times 8.5 would be 7.99. So that is going to be our side length. All right, let's try another one. Number 2. In a right triangle with one angle measuring 40 degrees, the leg opposite the 40-degree angle is 5 centimeters. What is the length of the hypotenuse? So every one of these, I do encourage you to make a nice sketch. It does not have to be to scale. If that bothers you, you can always resketch it. All right. So we're going to put a 40-degree angle in here, and the leg opposite the 40-degree angle is 5 centimeters. Okay, what's the length of the hypotenuse? So let's call that hypotenuse x. So once again, we're talking about the opposite side, and we're talking about the hypotenuse, and then we're talking about this angle. So opposite divided by hypotenuse, opposite over hypotenuse, is what we're talking about here. So opposite divided by hypotenuse would be 5 over x, all right? And then we're referring to that ratio for a 40-degree angle. So the opposite divided hypotenuse ratio for a 40-degree angle. So let's look back at our chart. Opposite divided by hypotenuse, which is this right here, for a 40-degree angle, 0.643. All right. 0.643. So 5 divided by x is 0.643. All right, so just like the other one, we're going to solve for x, but notice now x is in the denominator. So algebraically, this is kind of a two-step problem. We could treat it as an algebra problem, and if I were going to do that, first thing I would do is multiply both sides by x, just kind of like we did on the last one, only x is what's in the denominator, because that takes x times 5 divided by x, which just cancels that out to 1, or 1 times 5, which is 5. And over here we have 0.643x. We're not quite there yet. So now divide to undo. If we're trying to get x by itself, we're going to undo this multiplication by dividing both sides by 0.643. And that means x is going to be equal to 5 divided by 0.643, which is about 7.78. Okay. Now, in problems like this, another way to think about it, if we had something like 5 over x is equal to 0.643, another thing you could do is think of that as a 0.643 over 1, and then do our cross multiply and divide. We've done that before. So 5 times 1 is 5 is equal to x times 0.643. And then, essentially that gets you to this step right away. So it sort of avoids that first algebraic step. So you could divide by 0.643 now, and you get that x. So that's another way to think about that problem if you would like to solve it that way. So when the variable's in the denominator, it does essentially require one extra step. Okay, number 3. What is the length of segment DE? All right, so our right angle's up here, and our angle that we're referencing is here, and DE would be this side over here. So let's call that x. All right, so let's think about our angle and what we have here. So remember, the side opposite the right angle is going to be the hypotenuse. So neither of those sides is the hypotenuse. So this side right here would be opposite the angle, and the 6 right here would be adjacent, right? Because the hypotenuse would be over here, and we're not using the hypotenuse. So once again, we have an opposite and adjacent. So we know that opposite divided by adjacent is one of our ratios that we've talked about. And in this case, it's x is opposite, 6 is adjacent, and 50-degree angle. So 50-degree angle for opposite divided by adjacent. So that would be this last column again, and 50-degree angle right here would be the 1.192. And fortunately for us, this one is a little bit easier again because the variable is in the numerator. So just like before, to solve this, we'll multiply both sides by 6 to undo the dividing by 6. And x is equal to 1.192 times 6. So multiply these two together. 1.192 times 6 turns out to be 7.152. All right, last one. This one we're estimating the angle D. So we know actually all the side lengths, and in this case we're looking for angle D. So you might want to just think about what ratio you want to use. You have the opposite side, you've got the adjacent side, you have the hypotenuse. You could use any two of those together. So if you really like the opposite divided by the adjacent relationship, then go ahead and do that. So opposite divided by adjacent, in this case would be 7.7 divided by 6. If you prefer opposite divided by hypotenuse or adjacent divided by hypotenuse, you could also do that. I'm going to choose to use the opposite divided by the adjacent. So let's divide those two, 7.7 divided by 6. So opposite divided by adjacent, in this case, as a decimal, would be 1.283. So 7.7 divided by 6 is 1.283. All right, so now let's go back to our chart and see if we can estimate that. So opposite divided by adjacent, I think is that last column, and 1.283 is what we're looking for here. So 1.283 will be somewhere in here. Okay, so somewhere between 50 and 60, and we think about what it's closer to. It's definitely closer to the 50-degree side than the 60-degree side, 1.28 versus 1.73 versus 1.19. So yeah, we have to estimate it's closer to 50 degrees, definitely less than half. I don't know, maybe like 52 degrees. Again, at this point we're estimating, so I would take answers that are, a degree or two different than that. But for now, we're going to estimate. We are going to get more precise later. We're not always going to estimate. But for now, I just want to get this conceptually by doing some estimation. So that's it. Hopefully, a few of those example problems will be helpful as you take a look at the practice in the homework.